All righty, we are on October 16th. This is Thursday class. We're lessons 25 and 26 today. And so I only got three students on right now. I'm not sure where everybody else is. Maybe somebody told me they'd be gone today. Maybe others are just about to join us. So can you hear me okay? Thumbs up. All right, let's roll. Cool beans. All righty. Let's do this. I'm going to show you something. I kind of wish more students were here. Hopefully they'll watch after the fact. And let me pull up the whiteboard here. And I need to make this bigger. All right. There we go. And all right. Let me pull up my pen here, my handy pen. I'm going to remind you something we learned in Algebra 1. We're going to multiply these terms here. And there's actually three different ways to do this. I've taught you all three ways if I taught you Algebra 1. And I'm going to remind you of all three ways. And then we're going to get you a fourth way on how to multiply these two terms. So my preferred method is the stacking method. So watch x squared plus 3. This is a little bit of review for you. We've not done this yet this year, but we have done this in previous maths. So I'll multiply all of this. I just wrote these down. Oh, this is not the problem that we're actually working on in front of you. So I'm going to show you, this is an actual problem. We're not doing number 11 just yet. So it just so happened that the terms were similar, but a good catch, but that's not quite a hash mark. So, and then we'll get to this problem number 11. So I'm going to show you this. No, that's not, you're actually good eye. We almost could give you a hash mark for your eagle eye, Mr. Darcy. And, but the way we solve this problem is this. 4 times 3 is 12. 4 times x squared is 4x squared. Okay, if you've not ever done this before, let me know because I'm assuming that you did this a year ago or 2 years ago in Algebra 1, and I'm reminding you of it. So you multiply this by this spot, this by this spot here. So there to there, there to there, just like you would do if you were multiplying 73 times 24. You'd multiply 4 times the 3, you get the 2, the 12, the 29, add a 0 because you're going from the 10 spot, 6 and 14, and then you add them together, right? That's what we learned in the third grade or the fourth grade. Here we're just multiplying 4 times 3 to get 12, 4 times x squared to get 4x squared, okay? Now we take the x squared here and we go x squared times 3 is 3x squared, and x squared times x squared is x to the fourth power. So we have x to the fourth power plus 7x squared plus 12. Okay. Does everybody remember how to do that? Yes? Okay. There's another way to do it as well. It's called the FOIL method, okay? And this is the most preferred in curriculums to teach. It's not my favorite method for a few reasons, and I'll share why later. But it is, you'll see how in some ways it's easier to do. FOIL is an acronym. It stands for first, outer, inner, last. So we multiply the first terms, the x squared times the x squared to get x to the fourth. The outer x squared times 4 is plus 4x squared. The inner, which is 3 times x squared, is, you'll see you'll get the same exact thing we had before. And then the last, and that's 3 times 4 is 12. Then you just combine like terms in the middle, get the same exact answer, okay? All right. We also, I'm not going to teach you a third method that I taught you once before. It's the box method. That's my least favorite way, but I'm going to show you another way that they're teaching you now that might benefit you when you get in a more complicated problem. So you've learned how to stack and multiply. You learned how to do the FOIL method, okay? What you can do is this. You can take this value and multiply it by both of these like this, and take this value and do the same, and then combine all the like terms. Okay. So I broke apart the second parenthesis. You can break apart the first parenthesis as well. It doesn't matter. You're going to get the same exact answer. So all you're doing is you're breaking apart these two values and multiplying them. First, this x squared by both of these, as I've illustrated here, then the 4 times both of those, and then any like terms you have to combine. So x times x squared is x to the fourth. X squared times 3 is plus 3x squared. 4 times x is going to be just 4x squared. I mean, it's kind of the same thing. All of them kind of are. It's just in the 4 times the 3 is the plus 12. And now you could just get the same exact answer. Okay. Okay. So that being said, that's just another way that you can use like a reverse distributive property here when you do these problems. All right. So what do you think on that? Does that sound reasonable? And again, it's just basically doing the same work, just a different format. And the box way, I want to show you how to do that. So that being said, let's look at number 11, because we have the area of a rectangle, which we know is length times width. Okay. And so they're saying that this particular rectangle is x plus 4 centimeters. And this width of this rectangle is x plus 3 centimeters. And Hawkeye, Mr. Darcy over there, the illustration that I gave you, the x squared plus 4 and the x squared plus 3 multiplied together, is part of the teaching textbooks in the teaching portion. And it just so happened that they use similar terms without the squares. So let's go ahead and do this. Again, we can do it one of 4 different ways. We can let James on. He's jumping on right now. All right. So if you're just joining, a couple of people just jumped on just recently. I am recording this. It'll be on the YouTube channel. I showed you a new way to multiply when you have, a parenthesis of x plus 4 and a parenthesis of x plus 3. And so let's go ahead. This is number 11 on 25. So there's no squared here, so it'll be a little different, but it'll be very, very similar. So 3 times 4 is 12. 3 times x is 3x. X times 4 is 4x. And x times x is x squared. We add those together. Everybody's jumping on late today. We have x squared plus 7x plus 12. So the answer to number 11 is D. Okay? All right. Now, when we get down to 16 and 17, I'll do these again. And for a couple of you jumped on late, and the teaching earlier, I taught you a new method on how to multiply these binomials here like this. And we already learned 3 ways last year in Algebra 1 or 2 years ago. And I taught you a 4th way right now. And so that's on the teaching. But we'll get to that again when we get to 16 and 17, because 12, 13, and 14, and 15 are just going to be reviews on such. Okay, so let's do this. Let's do 12, 13, 14, and 15, and just to make sure we understand how to do those. Does anybody not have a sheet? Was there anybody not here on Tuesday? I think everybody in this class was here. I was missing a few people in the other classes. So I want you to number 12 is A, B, C, D, or E. Then we'll do 13. Then we'll do 14 and 15 as a form of review. If you think you have the answer, go ahead and send it over. Okay, got one answer so far. That looks good. Anybody else? You're all Mr. Soto. Why would we even do the work when you're about to do it for us and give us the answer? All right. Yes, that is the correct answer for, yeah. Well, one person didn't. Yeah. Okay. Let's remember this. When we add or subtract with variables, we must first look to see if the variable is the same letter. In this case, it's both X. So we're good there. It's not X and Y or A and B. It's both X. We have to have that. And we have to make sure that they're to the same. This little thing I have, this little marker, has been weirding out lately. It did it earlier in my last class. Not sure why it's doing that. Like spazzing on me. Yeah, see, I don't know why it's doing that. Let me plug it in. Maybe it's running out of juice. I don't like to have this little thing draping everywhere, but I charge it up before I do this, but maybe it's just running low. So maybe that's why it's acting funny. Okay, so, oh, I'm sorry, that's not right. 2.5. Say, if that's the case, then we can subtract it. And we just leave the variable the same. 2.5 minus 5.5 is going to be negative 3 x to the third, letter C. That's the correct answer for number 12. Okay. So good job, good job. Those of you sent it over, you all got it right eventually. So good job on that. Yes. Number 13. This is still acting really strange. Why is everything so weird today? 4x the fifth times 9x the third. Okay, now here, this is different because we're multiplying. All right. And so if they're on the same, if the exponents are on the same plane, we add them. Okay. We have to multiply the two coefficients together, then add the two variables. I'm sorry, the two exponents of the variables together. So what do you think for number 13, that being said? There's a lot of little nuanced rules here that you have to um, kind of figure out, especially on these types of things. Yep, you guys are getting it right. Those who are sending it over getting it right. Anybody else? Okay, so here I go, and this is number 13 on lesson 25, Dayton. It's 4x to the fifth power times 9x to the third power. So there's no addition or subtraction, so that's good. So these x5 and x3 can be put together. We look to see if they're on the all exact same level, the exponents, I mean, meaning not an exponent of an exponent, because we have to do that differently. If they're on the same level, we add them. If the variables are the same, you add the exponents. But we have to multiply the coefficients together. So 4 times 9 is 36. X, 5 plus 3 is 8. 36 x to the 8th power. Letter A is the correct answer for number 13. Okay, we are so smart. All right, let's go on to the next problem. This is multiplying here. This little thing is not working right. I can actually use my trackpad too. I've done that before. But this thing is really being a little spastic on me. Not sure why. What if I'm something I have making it be weird here? 14x plus 2 multiplied by 3x plus 6 over 7. Now, a couple things I want to tell you here. There's no equal sign in between, so you can't cross multiply. You can cross reduce because they're fractions multiplied by fractions. The Band-Aid technique that I taught you only works if you're on either side of an equal sign. Okay. If you're not on either side of the equal sign, you multiply numerator to numerator, denominator to denominator. But you can simplify, okay? So what I would do is this. I would factor this guy first. And remember, you can simplify if you have a plus or a minus in a numerator or denominator, provided everything is exactly the same. We'll put an understood parenthesis there. So I'd factor this, and then I'd simplify it. Then I'd simplify the 14 and the 7, and I'd get me an answer. So why don't you try this problem right here? It's number 14. I'm going to do it right here below. All right. All right. Anybody else? All right. So watch what I did here. Okay. I can't use the Band-Aid method, but I can reduce, cross reduce. It's just multiply a fraction by a fraction. So on this 3x plus 6, I'm going to factor that, the opposite of a distributive. There's a value that goes into each spot. I can pull it out. So I was able to pull a 3 out because 3 goes into 3 and 3 goes into 6, right? I pull the 3 out, and then pulling the 3 out of the 3x, I have the x left over. 6 divided by 3 is 2, so I have x plus 2 here. So now I have 14 over x plus 2 times 3 over x plus 2. Remember, on these addition and subtraction with variables in denominators and numerators, they can only reduce if they're exactly the same. Those x's cancel out. So now I have 2 over 1, 3 over, well, the 7 and the 14 cancel out as well. 7 and 14, that's fourth grade reduction, right? So I have 2 over 1 times 3 over 1, which is 2 times 3 is 6. 1 times 1 is 1. 6 over 1 is just equal to 6. Any number over 1 is equal to itself. The answer is letter E. On that problem only, which is number 14, thumbs up or thumbs down, or pointer finger in the middle. On a count of 3. 1, 2, 3, go. Okay. Number 15, looks like everybody's got it. We're actually subtracting. So remember, when we subtract, we have to have common denominators. So this would be a little bit, yeah, this thing is really spazzing out on me. That's really, maybe I need a new tip. Weird. You have to just learn how to navigate these hieroglyphics. All right, here we go. So let me just say this, okay, on this problem. I would first factor this, and then I would realize that all that's missing to have common denominators is multiplied by 2 here and here. So I multiply both by 2, and then keep the denominator the same, and then you just a negative minus this 3 that's right here. That makes sense? This is 3x for you. Sorry. Who is smarter than our students? All right, so yeah, let me just show you what I did so you can see it. I, this is the top problem here. Then I rewrote it. On the left-hand side of the minus sign, it's just missing a 2. So I multiply the top and the bottom by 2. The 2 times the -3, I just wrote it as -6x right here. It was -3x, but now I wrote it like this. And then this just becomes a common denominator. -2x minus 3x. I'm sorry, -6x minus 3x is -9x, all over 2x minus 18, because that you just redistribute that out. There's nothing else to reduce here because of the minus sign. Okay. The only thing you pull out is a 2, and the 9 and the 2 don't reduce down. So leave it like it is. Letter B is your final answer. All right. Number 16 is going to be similar to what we learned today. And then number 17 will for surely be like that. So all I'm going to do here is this. X times x is x squared. X times 3 is 3x. Okay. So now what I can do is this. X squared and the -4x squared is -3x squared plus 3x. Again, you want to do these in descending exponent order. That's why this goes first, because this x here is squared. This x is to the 1 power. So you do this one first. So -3x squared plus 3x, letter D. All right. Now here on this next one here, number 17, what I would do is I would use the stacking method. And I'm going to show you the new method I just taught you. A few of you jumped on late. Let's do it first with the stacking method. And we learned this in Algebra 1, so we know how to do this. My little pen is shaking. I'm not sure why. That's why it looks like I'm writing in ghostly writing or something like that. Okay, so I've just rewritten this, multiplied. It's always easier to put the smaller term on the bottom unless there's a lot of zeros there. So we'll leave it like this. I'm going to multiply 4 times 1 to get 4, 4 times 2x to get 8x, 4 times x squared to get 4x squared. Stop me if I'm going too fast. This is review from Algebra 1. Now I'll show you the new method, same exact answer. And again, why you need it is sometimes you will need to do it that way. But it's all good. X times 1 is x. X times 2x is 2x squared. And then x times x squared is x to the third. I just add these together. X to the third plus 6x squared plus 9x plus 4. And my answer is letter B. Do you all remember that and understand how we got that? Yes, thumbs up. Or maybe you didn't do Algebra 1 with me, or maybe you forgot, or maybe you don't know what I did. Thumbs down if you don't. Count 3. 1, 2, 3, go. All right. By the way, Ariana, where are your brothers? Are they playing hooky? Silly brothers. Okay, so here is the new way that we learned. This is the fourth way that we've learned how to multiply these binomials. The FOIL method, which I retaught you earlier today. The stacking method, which we just did right now. We won't do the FOIL right now. There's the box method, and I'm not even going to do that one. And then what I taught you today. So this is what you can do here, okay? I can rewrite this like this. This value, x, multiplied by everything here. This value 4 also multiplied by everything here, and then combine any like terms. Okay, let me go ahead and do that. So again, what do you do? This is the new method we just learned today. I know some of you came on late. You can take one of these binomials. This is actually a trinomial, but one of these binomials and just take both of the components out of it. Like this term here, the x, put it there. This term, the 4. Now, if this was -4, you have to say -4, which would change the value. That's why this method I don't love, but it's okay. It works. Okay. And then we just multiply out each spot, minding the term, the positive and negative signs. These are all positive, so it won't matter. But if they were negative, you have to be mindful of that. So let's just do that. We'll write them all down here, and then we'll combine any like terms we have. X times x squared is x to the third. X times 2x is 2x squared. X times 1 is x. Okay. Let's now go right here. Go 4 times x squared is going to be 4x squared. 4 times 2x is going to be 8x. 4 times 1 is going to be 4. So I just split apart this original binomial and took one of the values and multiplied it by all of this, took the other value and multiplied by all of that as well. And then they're all plus. So let's put a plus sign here because there's no minus signs anywhere. If there were, you'd be mindful of that, make it a little bit harder. Okay. So now we're just going to combine any like terms that we have. We have the x squareds here. There's no only one x to the third power. So we have 4 plus 2 is 6x squared. 1 plus 8 is 9x. And then just the 4 left over. Same exact answer. Okay. We've never taught you that way. First time learning it that way. Maybe other curriculums or some of you took Algebra 1 with different people. So maybe you've already done that. First time we've learned it that way. Any questions on that problem? All right, turn your papers over. Let's get to the next lesson. And we're going to say, when we had y6, these are made up values here, y squared. Okay. So we could rewrite this. We know that a fraction is basically division. If we want to write y6 like this, we wouldn't do all this, but we could do this though. We go y6 over y squared, right? And then the top and the bottom could cancel out. And then we could just say, these are all ones. So it's 1 plus 1 plus 1 plus 1, y to the 4th power. Okay. Or we could learn this method. Okay. Yeah. So y6 over y squared, y to the 6th power over y squared reduces to y to the 4th power. But we could also do this. I mean, this is not new, I don't think either. We learned this in Algebra 1. I think. If not, we're learning it now. We could actually do this, though. Anytime you see a problem like this with a variable on top, a variable on the bottom, if the variables are the same, we could write it like this. Watch. Y 6 minus 2. The numerator's exponent. I think my jacket, when it touches the tablet here, is why that's making that shake like that. Maybe not. No, it's still doing it. Not sure why it's doing that, but it is. Okay. So you rewrite this as if the variables are the same, we could just say the numerator's variable minus, I'm sorry, the numerator's exponent minus the denominator's exponent. 6 minus 2 is 4. Y to the 4th power is the answer. Okay. So that's one thing. How many you've done that before with the minus, where you subtract the denominator's exponent from the numerator's exponent to get the answer? If you've done that before, put a thumbs up. Okay, well now you know. Not too difficult. Oh, he's trying to join and he can't. That's weird. How weird. I am I'm using my office, so I'm at a hotel business center because my wife and I are traveling right now. So, all right. So nobody's done that before. Well, now you know. Okay. I showed you why it's that way. Okay. Now let me show you something else, and I'll show you one other thing, and that's all we learned today. If we had this, now watch this, y over 3 over y over 3. Okay. Y 3 minus 3, y 0. Any term, whether it's a variable or a value to the 0 power is always equal to 1. Okay? And there's a reason why I think I explained one time before, and I probably got to refresh myself on why the good explanation is it's not 1, it's, as I said, it's not 0, it's actually 1. So if you had 725 to the 0 power, that would just be 1, not 0 to the 1. I have a very good explanation why that is. I don't remember exactly the why I don't remember it exactly right now to articulate it for you, but I will look at it on Tuesday, and I'll try to get you. Okay. So all that back to this original problem: y over 3 over y over 3 is equal to y to the 0 power, which is equal to 1. Okay. Let me give you one more. Y to the 2 over y to the 5. Okay, so let me show you what's going to happen when we do a problem like this. Okay, there's a couple different steps. You're going to do it the exact same way that you did to begin with. Y 2 minus 5. Okay, y negative 3. But you cannot have a negative exponent. It is mathematically in your final answer. It's like you can't have 0 as a denominator. You can't have a negative exponent. So the solution to this is this. Anytime you get to your final answer, you have a negative exponent. All you do is rewrite the reciprocal of it to the positive. Okay? So our final answer is 1 y to the 3. I'm sorry, 1 over y to the 3. Let me show you again. So there's 3 things that you're learning. The first one, y to the 6th over y to the 2nd squared. If the variables are the same and it's a fraction, you simply subtract the denominator's exponent from the numerator's exponent, y to the 4th. Final answer. If they are, I apologize for this doing that. I'm not sure why it's being so silly today. It's 3 minus 3, which is to the 0. I'm just going to use my trackpad with my hand on my actual trackpad on my computer as opposed to this little tablet thing because it's just being so weird. Okay. So y to the 0 is equal to 1. Okay, that's the second thing you learned today. And the third thing that you learned today, y squared over y to the 5th. And I could show you it this way too, with the y, and then y, 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 y. The 5th, these cancel out. Remember, this 1 has to stay because anything over 1 is itself. But if you have 1 in the numerator, it's got to stay. Understood 1 coefficient in front of every variable, right? That's how we get that 1. Now we have 1 over y to the 3rd. Okay? Or we could do it this way. 2 minus 5, y to the negative 3, right? But you can't have a negative exponent, so you rewrite it as over 1, invert it, 1 over, and when you do that, you take that negative exponent and you make it positive. All right, thumbs up, playing for in the middle, or thumbs down. on this. I guess it's new to you. You haven't learned that yet, but now you know. So if you kind of understand that, count of three, 1, 2, 3, go. All right. Perfect. Let's clear this off, and it's going to work again. Oh, it's starting to work now. It's pretty weird. Let's go to the teaching on lesson 26. This is going to be 2x squared times 3. I'm sorry, cubed. So this, if you rewrote this, it'd be 2 times 2 times 2, x squared times x squared times x squared, right? Because you're talking about the volume of this cube. So a volume is length times width times height. So it's 2x squared is one side cubed. So you have to cube everything. So 2, 2, 2. 2 times 2 times 2 is 8. X squared times x squared times x squared is x to the 6th power. Okay? 2, 4, 6. So again, 2 to the cube power, 8. X squared, remember, because this is a power of a power, you don't add them, you multiply them. They're not even, it's one power up. 3 times 2 is 6. 8x squared. All right? Why don't you try number 12? That was number 11. That was the actual answer. Letter D. All right. Let's go ahead and do number 12. You can try that one. Not too difficult. Remember, these are added together, these exponents, because they're on the same level. On the one I just did, it was the power of a power. That's why it multiplied. Good job, Ariana. You got it. Yep, you got it. Good job, everybody. All right, let's try number 13. Negative 2 over 9x squared minus 1/3 x squared. We're just subtracting these two fractions. Make sure your variables to the degree are the same, which they are. Then get common denominators and then, yeah, solve. Not really solve, but calculate. All right, letter E is the answer there. Hopefully you got that right. You guys want to do number 14? It's, yeah, why don't you try number 14? Those are good practice for you. Yeah, it's good practice. I'm going to just do the reciprocal right from the start on the page. And then also use the distributor property. So I did the reciprocal already, changed the sign, and then I also used the factoring method to reduce that 14x plus 2. Pull the 2 out, 7x plus 1 left over. Yes, I will do that. Okay, so these all cancel out. The 7x plus 1 and 7x plus 1 cancel out. The 3 and the 9 reduce to 1 and 3. This is understood 1. 1 times 3 is 3. Well, 1 times 3x is 3x. We have 2 times 1 is 2. Better D. All right, let me go back to number 13 because we're getting asked about that. So I'm going to try with my trackpad again because this little pin is shaky. I'm redoing number 13. Okay. Honestly, I don't need this parenthesis here because it's not changing any value. So I'm going to erase this parenthesis here. Okay. So I have two fractions, negative 2 9x to the fourth power plus a negative 1/3 x to the fourth power. Okay. In order to add fractions, we learned in the fifth grade that you have to have common denominators. We also learned in Algebra 1 that you have to, in order to add and subtract with variables, you have to have the same variable to the same power. And in both of these instances, we do x to the fourth, x to the fourth. So those will stay the same in the answer. Once we determine that these are the same, all we do is add or subtract the coefficients together. Okay, so I have a negative 2 over 9 plus a negative 1 over 3. So I'm going to rewrite this 1/3 as a fraction with 9 as a denominator. 3 goes into 9 3 times. 3 times 1 is 3. So I've simply rewritten this fraction here. I'm going to put it. I'm going to put x it out. So I've rewritten this 1/3 as 3 over 9 to make my denominators the same. Okay. And now what do I do is this. You subtract the numerators. This negative sign right here, I go a negative 2 plus a negative 3. A negative 2 plus a negative 3 is a negative 5. My denominator stays the same. I'm just going to show this today. And the x to the fourth power is my variable. All right, there's our answer. The negative can be in the numerator, or mathematically speaking, it can also be outside. That's exactly the same thing. And even in this situation here, you could write this if it helped you see it as a negative 2 plus a negative 3. Negative 2 plus a negative 3 is a negative 5. Negative 5, 9 over x to the fourth power. That a little bit clarify things for you? Mr. Darcy? Are you still a little confused? Okay, good. Perfecto. All right, let's do this. Number 15, y to the ninth power over y to the 13th power. All right, so we see what we got here. We have y over 9, y to the 13th. Just subtract 9 from 13, you get a negative 4. Since you can't have a negative exponent, you just rewrite it 1 because it's a reciprocal, right? Everything's over 1. You invert it. The 1 becomes a numerator. Y to the 4th power. All righty. On this one, on the next one, let me show you a couple things real quick. And we're about out of time, actually. Uh, well, actually, we're gonna call it a day right there. All right. If you have any questions on the other problems, let me know. And we are out of time. So, um, but anyway, lots to learn, lots of new things we're getting into. So, any last minute questions? I'll have this up on the YouTube channel if it helps you if you need it. All right.